thermal fluid sciences experts. This is ProReadyEngineer.
We are going to move to thermal conductivity. This is a very large lesson. Feel free to split it depending on your time and schedule, but I'm going to cover it in one video, if you will. You see, thermal conductivity is one of those very interesting properties, and it's extremely important for us. Thermal conductivity is how well a material conducts heat. See, if I have material and there is a source of heat hitting here, the heat has to move through the material to the other side, has to move through it. If the thermal conductivity is high, it moves very easy. If the thermal conductivity is low, it moves very slow. Let me calibrate you and give you the feel. Your car, you are down in Texas on a very hot day, or you are down in Saudi Arabia, and it's 125 F, and I'm not kidding you, 125, 130 F. Your car is parked. Your hood is metal. You go down, you touch the hood, and it's blazing hot. It burns your hands off. Because these metals have a reasonable thermal conductivity. They pump that very well. But deep inside your home, and the same sun is shining on your walls, it feels hot, but you can touch it. It's way better. Why is that? Because there are lots of insulation that makes it difficult for the heat to transfer. You see, when you buy these hot mugs that keep things hot and cold, how do they work? Like, what are they exactly doing? See, what they do is they have around where you put your stuff an air gap. So there's an air gap around it. Why air? Because air, see this air here? Thermal conductivity is very poor, very small number, 0.25 watt per meter Kelvin, meaning that air, if it's stagnant, if it's standing still, stagnant air, and heat tries to pass through it, it's very difficult for heat to pass through it, right? So this thermal conductivity, if K is high, you move heat quick. If K is low, you move K slow. So which is good and which is bad? This is not good and bad. It depends on what you need. If you are trying to insulate, I'm trying to insulate, I don't want heat to move, then you look for insulators. Like here, you see insulation is close to the air. So air is an insulator, right? Watt per meter Kelvin is the unit of thermal conductivity. How about if you want to move the heat? I want the heat to move. Where do we want the heat to move? Let's get an example. Well, your radiator. You know, in your car there's a radiator. This radiator, what it does is it's trying to cool down the hot water. So for what you want to do is actually move the heat. I want to remove that hotness. Then your radiator will be made out of copper or aluminum, because look at the K here, man, look at that, 400 watt per meter Kelvin, 200 watts, very large numbers. So you're going to move the heat very easy, and that's the application that you need, right? So when I go for a heat exchanger, is where you will see copper, aluminum, and sometimes not much you can do, because you cannot use aluminum or copper at some extreme conditions, and you have to go with steel, and steel will be way less than these, which means that it's not going to be as good, it's not going to be as efficient, it has to be larger in size, but that's okay, because that's the application. There's nothing cannot do better than that, right? So thermal conductivity concept is extremely important. You build a feel for the numbers, what the numbers mean, what is used for, and this equation is extremely important equation. You will see it in many of the applications as you progress in your career, but essentially what it says is something very interesting, that the heat transfer is proportional to the temperature gradient, and that proportionality constant is K. If you're not comfortable with the things I just said, that's perfectly fine, but all what it is If you bring a thick wall, you put a temperature here, large temperature, 400 degree, and you go to the other side, the amount of heat, that temperature that you will get, depends on the thermal conductivity of that piece of thing, that K. The amount of heat is proportional to that, right? That's all. This is what it means.